For the honors project this term, we're going to be doing a bridge design contest. We're going to do it using software. Each of you should have it installed on your school devices. If you don't, or you want to install it on a personal device as well, the way you will find that software is you're going to go to www.bridgedesignandbuildcontest.com www.bridgedesignandbuildcontest.com, and I'll link that in the video description. You're going to go to this site and you're going to go to Students and Student Resources. When you pull this page up, you can download the Bridge Designer for the current cycle 2022. When you select that, it will start your download. Open up your download and it will start installing it on your computer. It may come up as a potential threat, but you can go ahead and install it anyway. Let's take a look at how the software works as well as how to design some bridges using the software. We're going to start by looking at how to use the software for the Bridge Design Challenge. First thing you'll need to do is open up your Start menu, and once you do, select the newest version of the Bridge Designer. When it loads up, you'll get some tips as well as some design ideas. These are pretty useful to read through. I recommend doing it at some point. Once you've read through a few of them, you can click Close, and it will bring up this screen. From here, you have a couple options. You can either create a new bridge design, which is what we're going to do first. You can load a sample bridge design, or you could load an existing bridge design file. This is where, if you've been working on a design that you've saved and you want to come back to, that's how you'll do that. For now, I'm going to make sure it says create a new bridge design and hit OK. It's going to then bring up a menu that we have to work our way through. This is the basics of our site preparation, so getting the site ready to build. I recommend reading through these your first time through because they give you a lot of really useful information as you go through this challenge. Once we've read through it, we're going to click Next, and we're going to say that no, we are not participating in a local bridge design contest. We'll keep ours kind of separately. It's a different setup to use what they have there. From here, we have a lot of other options as to how we can do our site preparation and change the values here. For example, down at the bottom, you can see our basic site cost as it stands right now. We can change the deck elevation. I can do some excavation. I could put the deck all the way down at the river, which would minimize how much I would need to span, but it would also cost a lot to do that much excavation. So we'll set it back to 24. You can also change the type of abutments that are used. We have standard abutments and arch abutments. Arch abutments are used if you want to use an arch on the substructure. And if you select arch, you can change the peak of the arch, you can change how extreme that arch is, and each of these does have an effect on the cost, you can see as you go. We're going to stick with a standard abutment for now. You can also add a pier. Pier gives you an extra place to anchor your bridge, and you can increase the height of the pier up to the height of your deck. For this one, we're going to stick with no pier. You can also add cable anchorages. These come in handy for different types of bridge designs, but for our first design, we're just going to select no cable anchorages. And then again, we read through our design tips, and we can click Next. From here, you can choose different types of deck materials. You can use medium strength concrete or high strength concrete. The high strength concrete costs a little bit more, but it weighs a little bit less. So there's a trade-off. Sometimes it's useful, sometimes it isn't. We're going to stick with medium strength concrete for the one that we're doing together. When you start doing your own designs, you can pick whatever materials you want for this, as well as whatever site conditions you want. For loading, we're going to do standard loading. We're not going to select permit loading, just a little bit different way that it is tested. So we will stick with standard loading and click Next. These are some templates. You're free to use these as you're starting your designs, and in fact, your early designs, I recommend using them. because it gives you an idea what a good bridge will look like. But for this one, we're going to do a deck truss, and we're going to do a deck truss of a how design. We'll select that and select next. When it comes to this, you will have some information that you'll have to fill out. Anything with an asterisk by it will require a submission before you can advance. I'm just going to plug in my name here. This is the bridge one that I've designed, and plug in my team name, and I am sadly a team of myself. So I've got all that plugged in. You'll notice the next and the finish aren't yet up. I just click on another box and it will bring it up. So I have my designed by, my project ID, team name, and team members' names, excuse me. I can then click next, and then it gives a bit of a tip that I recommend reading through, and then I can click finish. From here, I have a lot of different options. The first menu you'll see here, your tools. The circles are your joints. These are where the steel members will be connected. If you click this one, this allows you to draw those steel members. The pointer is a selector arrow, and then of course the eraser will delete whatever you are on top of. A couple other useful tools here. You can bring up measurements over here as well as grids, and you can change the drawing grid. So you can see right now I can move my cursor a little bit before the draw function moves it over, because I have a very coarse drawing grid. I can select medium or I can select fine. So you can see as I make adjustments with the fine, it makes much smaller jumps. For this one though, I'm just going to go with the coarse grid, and I'm going to basically fill it in from the template. So I'm going to add in all of the joints by simply clicking where I want them. And there's a couple different ways that you can draw members. You can either draw each individually, or you can click and drag to draw all of them at once. And each joint it passes, it will put a new member in between. And over on the right, you can see that I have 9 members currently added to this. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to continue filling in. So I have everything filled in right now. You can see each of my members over here. You can see the material type, which can be changed up here. The material types are carbon steel, high strength, low alloy, and quenched and tempered. You can either erase and do it, or you can highlight over here. You can also see the cross section. All of these are bars. You can also select hollow tubes. And then you can see the size and the length of each of the members. Slenderness is a function that measures length versus the size. This could cause a bridge to fail because of a code. Your slenderness value can't exceed 300 for a member, barring certain external circumstances. So let me select a member here. So this is the last member drawn in. I currently have a slenderness value of 139.97. There's a couple different ways that I can make this smaller. I can either click the drop-down menu, and you can see I can make it all the way up to 500 by 500, or I could go all the way down to 30 by 30. And you'll see when I did that, this number for slenderness became pink. That tells me that this violates a building code, and I can't have a member that small in that place. So I'm just going to set it back to the default, which is 140 by 140. Up here you can see how many iterations I've gone through, how many different designs I've tested. When you select the drop down, you can go back through old iterations. Like if you had a good design that you wanted to tweak a little bit to see if it got any better, but it ended up not, you can go back to those old designs that way. Here you can see the cost of your bridge, and if you click the calculator beside it, you can see exactly where your price is coming from. So this bridge currently costs $378,000. The status of the bridge here tells you whether it passed or failed the load test, or in this case, this design is untested, which means I haven't run the load test. So let's go ahead and run a load test. Over here, you can see your drawing board as well as what looks like a truck. So we're going to run the load test. So I click that, and over here on status, my bridge has failed. Certain members of my bridge have not successfully passed the load test. When you're here, you can change a couple of options. You can hide the background, you can hide other elements of it, you can take the colors out. I recommend leaving those on because you can see the different, whether they're under compression or tension. And this is an extremely exaggerated bend in this bridge, so you can click that and take the exaggeration off, and you can run the test again. So if I go back to that and just run the test, I have the exaggeration off, but you can see that my bridge has still failed. So let's go back and see what it's showing. So anything over here that has color has failed. So these three members failed a tension test. There's a couple different ways you can address that. One of the easiest ways to address it is to click and highlight, and I'm going to highlight all three of those members. And I can either, again, go to the menu, or I can click the size up and size down. So size up and size down. I'm going to make them all 1 bit bigger. So they are now 150 by 150. I could now go in and change all the compression ones, but for now I'm just going to see if that fixed those three members. So I'm going to run a load test. I know it's not going to pass, but I want to see if I fixed those three members. So I come back to here, and all three of those members have now passed the load test. So now I can address the ones that have failed it on the compression end. I'm going to highlight all of those. Now a trick to highlight members that aren't side by side, you can click and drag to highlight. If you hold Control and click, you can highlight a member that isn't sequential. So I'm going to hold Control and click. I'm going to make them all 1 click larger and run the test again. So I can see that it has still failed. So I come back here. I see all of the ones that I had just changed. Several of them are now passing, but I still have 5 that aren't. So I'm going to select those 5, make them a little larger, and run it again. I'm still failing. So let's go back to our drawing board. Of the 5, 1 of them's now passing, but the other 4 aren't. So I'm going to make them a little bit larger. Run the load test. It's still failing. So 4 of them. Now all but 2 of them have passed. I'm going to select those 2, make them a little bit larger, and you can see now I have a green arrow. This has passed the load test. And if you want to see exactly what's going on in your bridge, you can turn your exaggeration on. You can see exactly how that bridge is being supported as the truck is driving over it. You can see those members going into compression and the members along the bottom going into tension as that bridge is driving over. From here, my challenge is to minimize the cost. So there's a couple different ways I can do that. I can sort by compression strength and tension strength. I can decrease the size of certain members. For example, these members right here have very low tension force per their strength. As long as this number is less than 1, it will pass the load test. So these aren't very close to 1, so I can make them all a little bit smaller. So I've selected them all. I'm going to make them 100 by 100, and then let's run the test. It's still passing, so I can see that it passed. I can go back. Ooh, I see a couple have shot up to 0.96 and 0.95. I probably can't make them any smaller, So I'm going to deselect them by holding Control and clicking on them again. But the others that I have highlighted here, it looks like I can make even smaller. So I'm going to go down to 75 and run the test again. So it is still passing. So I can go back. I've got 0.81, 0.79, 0.60. Let's try going a little smaller. Still passing. So I see 2 here that are getting close. Let's see if they pass if I make them any smaller. When I did that, I see I had 2 that failed a slenderness test. So I'm going to make them all a little bit bigger, and I'm going to deselect the 2 that failed the slenderness test, make the other smaller, and test it. So I have now broken my bridge, but I can go back. I've only had 2 that failed, so I can just select those 2, make them larger again, and run the test. So in a couple of minutes, I started with a bridge in the $400,000 range, and I've knocked it down to about $360,000. And there's a lot more I can do by changing the types of steels, changing the structure of the steel members. This will allow me to minimize costs in different ways. So your challenge will then be to figure out how to minimize the cost of each of these designs. So there's a lot of different ways you can do it. When you are done or you need some break, time away from it, you can do File, Save As, and save your design on your computer to come back to at any time. This will also be how you'll want to save it before you upload it to Schoology. If you have any questions, please reach out, but the biggest part about this is have fun, try a bunch of different bridge designs, see what works, and see what we can do cheaply.